Brought to you by the Dark Lord himself, Queasy Ali. It is the most recognizable silhouette on Earth, an ancient postcard from the dawn of history, the Great Pyramid of Giza. We are told it is a 4,500-year-old tomb for a god-king, Pharaoh Khufu, raised by 100,000 workers with copper chisels, ropes, and brute force. It is the story we all grew up with, a triumph of human grit and ingenuity. But when you start pulling on the loose threads, that neat story doesn't just fray. It comes apart. To build this monument in the accepted 20-year window, the builders would have had to quarry, shape, haul, and perfectly place roughly 2.3 million stone blocks. That works out to one multi-ton block every 2.5 minutes. Every 2.5 minutes, 10 hours a day, 365 days a year, for 2 straight decades. No holidays. No Nile floods. No supply delays. No human error. No bad seasons. That is not a challenge. That is a logistical fantasy. And that is just the first crack in the story. Because once you strip away the museum labels and the textbook certainty, the Great Pyramid starts to look less like a royal tomb. And more like something else entirely. Something anonymous, precise, and deeply technological, inherited by the Egyptians rather than invented by them. Tonight, we're going to follow the evidence wherever it leads, through silent chambers, suspicious hieroglyphs, impossible engineering, geological scars, lost civilizations, and finally into a theory that sounds insane until you realize how much of it is backed by hard data. The theory that the Great Pyramid was not a tomb at all, but a machine. A machine that once turned the Earth itself into a power source. And that the same forces that destroyed that machine once before might have almost wiped us out too. So settle in. Because once you see this, you won't look at Giza, history, or our own future the same way again. The first problem is not a block of stone. It's a wall of silence. The ancient Egyptians were obsessive record keepers. They documented everything: grain tallies, tax disputes, storehouse inventories, religious festivals, even workers complaining about their rations. We have king lists carved in stone, like the Palermo stone, that track royal deeds year by year. We have inscriptions bragging about the construction of smaller pyramids, modest temples, minor public works. They carved their victories into walls. They painted their theology inside tombs. They were not shy about taking credit. And yet for the single greatest construction project in their entire history, the Great Pyramid, there is no clear contemporary record at all. Not one unambiguous inscription from Khufu's time that says, "I, Khufu, built this pyramid." No detailed building stele. No project log. No papyrus archive chronicling the greatest logistics miracle of the ancient world. Imagine modern China building the Three Gorges Dam with no paperwork. Imagine the United States running the entire Apollo program and somehow producing no official records. That is the scale of the silence we're talking about. Faced with this, Egyptology leans heavily on a single piece of smoking gun evidence: some red quarry marks in hidden relieving chambers above the so-called King's Chamber, discovered in the 1830s by an English adventurer named Colonel Howard Vyse. Vyse was under immense pressure. He had blasted his way into the pyramid using gunpowder. His sponsors expected results. He needed a discovery. At the end of one explosive campaign, he announced that he had found painted marks left by ancient work gangs. Among them, a cartouche, an oval containing the royal name Khufu. There it was. The link. Case closed. Except the story around that discovery is murky, and the glyphs themselves raise eyebrows. Some of the signs, including the crucial spelling of Khufu's name, contain mistakes and stylistic quirks that do not match formal 4th dynasty hieroglyphs. But they do happen to match examples printed in a popular 19th century Egyptology book that Vyse owned. Critics have suggested a simple, ugly possibility, that someone on Vyse's team, desperate for a breakthrough, copied the cartouche out of a book and painted it on the chamber wall before discovering it. Whether that happened or not, the fact remains that this controversial graffiti is the only direct link between Khufu and the Great Pyramid. If it falls, the official attribution has nothing left to stand on except tradition and inertia. But even if we give the orthodox story every benefit of the doubt, Khufu really did build it, Vyse's marks are genuine, we still smash face first into the math and the engineering. The base of the Great Pyramid covers over 13 acres. The 4 sides are aligned to the cardinal directions with astonishing precision. The error relative to true north is less than 1/15 of a degree. The base is leveled to within about an inch across its entire footprint. We can replicate that kind of accuracy today using laser transits, GPS, and computer modeling. The idea that a Bronze Age culture with copper tools and knotted ropes casually did this on uneven bedrock is already pushing credibility. Then you look at the alignment. The north-south axis matches true, not magnetic, north. That requires long-term astronomical observations, an understanding of precession, and extremely careful application on the ground. The conventional explanation is that the Egyptians used sighting stars and a simple plumb line. Perhaps. But perhaps starts to sound thin when you remember that this level of alignment was not matched in a major structure again until the 19th century. Now we come to the stones. The pyramid's core is made of limestone blocks averaging around 2.5 tons each. But the real monsters are the Aswan granite blocks in the interior, especially in the king's chamber and the ceilings above it, which weigh up to 70 or 80 tons apiece and were quarried more than 500 miles to the south. Mainstream reconstructions suggest these were floated down the Nile on wooden barges, unloaded at Giza, dragged up ramps, and hoisted into place. On paper, that sounds heroic. But put yourself on that riverbank for a second. You have a block the weight of a modern battle tank. You have a wooden hull, Bronze Age carpentry, and a river with currents and sandbanks. You have to load the stone without snapping the boat like a twig. Then you need to get that boat and that cargo all the way to Giza, unload it, haul it uphill, and somehow raise it more than 200 feet into the air and set it down with millimeter-level precision. Every proposed ramp system runs into the same wall. A single straight ramp long and shallow enough to haul stones to the summit would require more material than the pyramid itself. A spiraling ramp hugging the sides would block the corners and prevent the builders from checking alignment. And in either case, you would expect to find some trace of these colossal earthworks in the archaeology. We don't. While artists and textbooks love the image of long ramps and armies of workers, physical evidence for such ramps at Giza is tenuous at best. The solutions feel like they were picked to save the theory, not because the stones demanded them, and the stones themselves tell a different story. The original casing stones that once covered the pyramid in gleaming white Tura limestone were cut so precisely that early visitors reported you could barely see the joints. Where some still exist, the blocks meet so tightly it is difficult to slip a blade between them. The faces are flat to incredibly small tolerances. The interior granite surfaces in places are even more precise. Copper chisels and pounding stones can do a lot over time. But they do not naturally produce surfaces flat to within thousandths of an inch over several feet, perfectly square internal corners in hard granite, or drilling patterns that look suspiciously like the work of powered machinery. That's not speculation. That's what you see when you bring a machinist, not an archaeologist, to Giza. British-born engineer Christopher Dunn spent decades working in high-precision manufacturing before turning his eye to the pyramids. When he inspected granite artifacts like the so-called sarcophagus in the king's chamber and cores drilled out of granite in the 19th century, he did what any machinist would do: he measured them. On the granite core made famous by early Egyptologist Flinders Petrie, Dunn noted a continuous spiral groove wrapping around the cylinder. From its pitch, he calculated the drill had advanced through the stone at something like 1 inch of depth for every 100 revolutions. That feed rate in hard granite is extreme even by modern standards using diamond-tipped, computer-controlled tools. To achieve it in the ancient world using a handheld bow drill with sand as an abrasive is not just difficult. It is basically impossible. He also noticed the cut behaved differently in different minerals. The groove is actually deeper in the softer feldspar than in the harder quartz crystals. That is the opposite of what you expect from a simple loose abrasive slurry, but exactly what you see when a rigid cutting edge under high pressure and speed interacts with a mixed material. The tool bites deeper where the resistance is lower. Dunn's measurements of flatness on some granite surfaces return tolerances we use today for optical components. This is not the random outcome of brute force. This is controlled, guided machining. So whatever else the Great Pyramid is, it is not the sloppy, symbolic pile of stones that popular culture sometimes imagines. It is a piece of ultra-high precision engineering on a megalithic scale. Which brings us to an uncomfortable question. If it is not behaving like a tomb, why are we so committed to calling it one? Walk inside the Great Pyramid and compare it to every confirmed royal tomb in Egypt. In the Valley of the Kings, even in tombs looted in antiquity, you still find paintings on the walls, carved texts from the Book of the Dead, spells and star maps and long hymns to the pharaoh's greatness. You find fragments of sarcophagi, shattered grave goods, broken jewelry, pottery, canopic jars, residue of resins and wrappings. Even robbed tombs still scream burial from every surface. Inside the Great Pyramid, you find the opposite. No carved spells. No painted scenes. No pharaonic boasting. No grave goods. No mummy. The walls of the so-called king's and queen's chambers are bare, stark, and geometric. The granite box in the king's chamber is rough on the outside, oddly utilitarian, without inscriptions inside or out. When the pyramid was forced open in the 9th century by the Caliph al-Mamun, the box was empty. No lid. No obvious signs of burial. Modern tests have not found residues that would suggest a body ever decomposed there. To defend the tomb theory, we have to imagine that robbers somehow tunneled in, removed all the treasure, the mummy, the lid, every scrap of ceremonial material, cleaned even the dust of the dead pharaoh's wrappings away, and then melted back into history, leaving no mark of their own. Or we can entertain the possibility that the box was never meant for a corpse, and that the pyramid's interior is not a funerary landscape at all. The more you look at the Great Pyramid as a tomb, the less sense it makes. The more you look at it as a piece of precisely engineered unknown technology, the more its features start to look deliberate. And when people have tried to push that line of inquiry, they've run into another obstacle, not stone this time, but human. For decades, the global face of Egyptian archaeology has been Dr. Zahi Hawass. He has served as Secretary General of the Supreme Council of Antiquities and as Egypt's first Minister of Antiquities. If you wanted to dig, film, test, scan, or even breathe too close to a major monument, you needed his approval. In public, he is charismatic, passionate, fiercely defensive of Egypt's heritage. In debates, he has been blunt to the point of saying, about certain theories, the case is closed. I closed it, and I will close it again. That is not the language of a scientist chasing data. That is the language of a gatekeeper. Under this centralized system, researchers whose work supports the standard 4th dynasty tomb narrative have found it relatively easy to get permits. Those who propose radical revisions, older dates, unknown precursor civilizations, non-tomb functions, have often found themselves mocked, blocked, or frozen out. You see this pattern around geological studies of the Sphinx's erosion. You see it in the hostility to the Orion correlation theory, which links the layout of the Giza pyramids to the stars of Orion's belt. You see it in how discoveries inside the Great Pyramid itself have been managed. Take the Gantenbrink door. In 1993, German engineer Rudolf Gantenbrink sent a small robot up one of the narrow air shafts leading out of the so-called Queen's Chamber. These shafts don't open to the outside. They are 8 by 8-inch tunnels angling up through the masonry for hundreds of feet. Egyptologists had long written them off as symbolic or ventilation features. Gantenbrink's robot crawled up the southern shaft. After about 200 feet, it came face to face with a small limestone slab blocking the passage. The slab had 2 neat copper fittings embedded in it like handles. This was unprecedented. Worked metal, in a sealed interior shaft, in a place no human had seen for thousands of years. Gantenbrink wanted to continue exploring. Instead, his permits were revoked. Years passed. When another team was finally allowed to revisit the door on live television, they were permitted to drill a tiny hole through it and snake a camera inside. The world watched as the lens emerged into a small empty space. And another stone blocking the way. A second door. Another mystery. And then, once again, everything stopped. In 2017, an international team using muon tomography, a kind of cosmic ray imaging, announced the discovery of a massive void deep inside the pyramid above the Grand Gallery. The Big Void, as they called it, is on the scale of the Grand Gallery itself. It is undeniable. It is there. Something is inside the Great Pyramid that we did not know about 10 years ago. You might think the response would be, amazing, let's look. Instead, calls to drill a small fiber optic camera into that void have been refused. The find has been publicly minimized as just a construction gap without actually checking. So we have sealed doors with unexplored spaces behind them and a chamber-sized void hanging above the main internal staircase of the pyramid. If this is just a tomb and we already know the story, why not look? Why not be curious? Part of the answer might be that the more we seriously investigate Giza, the further back in time we seem to go. Just a short walk from the pyramid stands the Great Sphinx, lion's body, human head, enigmatic gaze fixed on the eastern horizon. The official date for the Sphinx is about 2500 BC, attributed to Khafra, builder of the second pyramid. But unlike the pyramids, the Sphinx is carved directly out of the bedrock in a deep enclosure. And that enclosure tells a different story. Independent researcher John Anthony West noticed that the walls of the Sphinx enclosure are not etched by wind and sand in neat horizontal lines like other structures on the plateau. They display deep vertical fluting and rounded, undulating surfaces that look, to his eye, like water erosion. He took the question to a professional geologist, Dr. Robert Schoch of Boston University. Schoch had no horse in the race. He went to Giza, examined the stone, and came to a stark conclusion: those weathering patterns are classic precipitation erosion. They require significant, sustained rainfall. The problem is, Giza has been bone dry since well before the Old Kingdom. To get that kind of rain, you have to go back thousands of years earlier, into the epoch when the Sahara was green and the last ice age was ending. Schoch suggested the core body of the Sphinx might be at least 9,000 to 12,000 years old, later recarved in the pharaonic era. Egyptologists rejected this out of hand, not by disproving the geology, but by insisting that the archaeology must be right because the Sphinx must belong to Khafra. Then came the sky. Engineer Robert Bauval noticed that the three main pyramids at Giza, two big ones in a row and a smaller one offset, look uncannily like the three stars of Orion's belt. Using astronomical software to roll the sky backwards, he found a moment when the belt's angle over the horizon matches the layout on the ground almost perfectly. Around 10,500 BC, at that same moment in the precessional cycle, the Nile corresponds to the Milky Way, and on the spring equinox the constellation Leo rises in the east exactly where the Sphinx, a lion-bodied figure, is looking. Two different scientific disciplines, geology and archaeoastronomy, arrive independently at the same deep date, a window around 10 to 12,000 years ago. An era we usually associate with hunter-gatherers, not pyramid builders. Which raises another uncomfortable thought. What if the Old Kingdom Egyptians were not the first high civilization at Giza? What if they were the inheritors? Journalist and author Graham Hancock has spent decades arguing for the existence of an advanced Ice Age civilization that was destroyed in a global cataclysm and partly remembered in myths as Atlantis, Zep Tepi, and other first times. According to this view, a maritime culture with sophisticated knowledge in astronomy, surveying, and stonework flourished before the end of the last Ice Age. Then something terrible happened. Around 12,800 years ago, the Earth plunged back into a brief deep freeze known as the Younger Dryas. Then, roughly 1,000 years later, it snapped out of it in a geologic instant. Ice sheets melted, sea levels rose roughly 400 feet, coastlines drowned, climates went wild, and many megafauna species vanished. Evidence is piling up that at least part of this chaos was triggered by a series of cosmic events, either fragments of a disintegrating comet striking the ice sheets, or violent solar outbursts that overwhelmed our magnetosphere and rained plasma and radiation down on the planet. Either way, the result would have been apocalyptic: continent-scale wildfires, black rain, shock heating, meltwater floods scouring the land and anything built upon it. In that scenario, an earlier coastal civilization could have been almost completely erased in a geological blink, leaving only a few inland or high-elevation refuges like Giza. The survivors, scattered and traumatized, would spend generations trying to restart. They would be remembered in later myth as gods or civilizers who brought agriculture, architecture, and laws to more primitive peoples. If that sounds fanciful, look at Göbekli Tepe in modern Turkey, massive T-shaped limestone pillars carved with animals and abstract symbols, arranged in circular enclosures, intentionally buried and dated to around 9,600 BC, right when the Younger Dryas ends. That is 6,000 years older than Stonehenge and 7,000 years older than the orthodox date for the Great Pyramid. By every old textbook model, hunter-gatherers of that era should not be organizing workforce, quarrying, and megalithic architecture like that. And yet, there it is. Look at the Ossuran at Abydos, huge granite blocks fitted in a stark, megalithic style, sitting lower and more weathered than the decorated temple of Setia that wraps around it. Look at the astonishing granite boxes in the Serapeum of Saqqara, each weighing around 100 tons, carved from single blocks, polished to mirror-like flatness, with internal corners so sharp it is hard to imagine them produced without guided machinery. Look at the polygonal masonry in Peru, the trilithon blocks at Baalbek in Lebanon, and other anomalies scattered around the world that seem to hint at a shared, deeply ancient engineering tradition. You begin to see a pattern, a global fingerprint of an older, high-skill culture whose masterpieces were later adopted, repurposed, or copied by younger civilizations. If that is true, then the obvious question becomes, what exactly were these people doing at Giza? Because if the Great Pyramid is not just a tomb, and if it was designed by a culture that understood the earth, the sky, and stone at a level we are only now catching up to, maybe its purpose was not primarily symbolic at all. Maybe it was functional. This is where one of the most controversial, and strangely compelling, ideas enters the story: the Great Pyramid as a power plant. To even entertain that thought, you have to look beyond the shape and consider the materials. Most of the core blocks are local limestone. But the pyramid was originally sheathed in polished white Tura limestone, quarried miles away. That specific stone has very low magnesium content and is a good electrical insulator. Inside, in key structural and chamber areas, the builders used Aswan granite, hauled from hundreds of miles to the south, which is rich in quartz. Quartz has a property called piezoelectricity. When you compress it or vibrate it, it generates an electrical potential across its faces. That is why quartz shows up in watches, radios, sensors, lighters. So we have an insulating outer shell, and an inner skeleton laced with piezoelectric granite. The King's and Queen's chambers, the Grand Gallery, and various passages are all lined or built with that granite. And they are not random caves. They are tuned spaces. Modern acoustic studies have found that the Grand Gallery resonates strongly around 440 Hz, the note A above middle C, in the same family as F sharp used in certain Earth resonance hype, but more importantly a clear, stable musical pitch. The King's Chamber also has strong resonant frequencies and behaves as a Helmholtz resonator, like blowing across the top of a bottle to make a tone. Engineer Christopher Dunn, taking all this together, proposed a radical model. Beneath the pyramid are natural aquifers and limestone cavities. As groundwater flows and sloshes through them, it creates low-frequency vibrations, literally the earth humming. Those seismic and acoustic waves travel up into the pyramid's foundations. Inside, in Dunn's model, chemistry kicks in. The two narrow shafts leading to the Queen's Chamber show traces of different compounds, hydrochloric acid in one, zinc compounds in the other. If those were once part of a controlled delivery system, their vapors or liquids mixing in the chamber could generate hydrogen gas. Hydrogen, light and reactive, would flow up into the Grand Gallery, which is lined with granite ramp-like ledges. Dunn envisions these ledges once holding rows of resonators, perhaps stone or metal devices tuned to specific frequencies, which would amplify incoming vibrations and focus them into the structure. As the granite vibrated at its resonant frequencies, the piezoelectric effect would generate electrical potentials. Hydrogen gas inside would become ionized, increasing conductivity and turning the gallery and connected passages into a kind of waveguide. A small rectangular opening leads from the top of the Grand Gallery into the King's Chamber. Its dimensions happen to be suitable for hydrogen-related microwave wavelengths. Above the King's Chamber are a stack of granite relieving chambers separated by gaps. Traditional archaeology says they are there to spread the load of the stone above. Dunn suggests they could also act as a tuned resonant cavity, focusing and sustaining specific frequencies. In 2018, a team of physicists ran simulations of how the pyramid would interact with external electromagnetic waves in the radio range. They found that, at certain wavelengths, the pyramid concentrates energy in its internal chambers and also underneath its base in ways that are not trivial. It behaves like a complex resonant object. In 2019, another study showed that when certain rocks vibrate, electrons can migrate to the surface, effectively creating a weak but real current. Granite is one of those. Put all these ingredients together: groundwater vibration, tuned acoustic spaces, piezoelectric materials, resonant cavities, hydrogen as a working fluid, a conductive atmosphere, and an exterior shell that insulates, and you no longer sound like a lunatic when you say, "This looks and behaves like a gigantic, Earth-coupled energy device." Not a nuclear reactor. Not a coal plant. Something else. Something that uses geometry, chemistry, and resonance to harvest tiny flows of natural energy and concentrate them. And then we notice the parallels with a man from our own history whose work was also ridiculed, suppressed, and stripped for parts: Nikola Tesla. Tesla believed he could tap into the electrical potential between the Earth and the ionosphere and transmit energy wirelessly around the globe. His Wardenclyffe Tower on Long Island was built over an aquifer, with long conductors driven into the ground, designed to use resonance and standing waves along the Earth's surface. He had already shown, on a small scale, that he could light bulbs at a distance with no wires, using tuned coils and the surrounding medium as the carrier. Wardenclyffe was the attempt to go big. He convinced financier J.P. Morgan to fund a global wireless communication system, then quietly pivoted to wireless power. When Morgan realized the implications, worldwide, practically free energy that could not be metered, undermining copper mines, telegraph companies, power plants, and all the infrastructure he owned, he pulled the plug. Tesla was blacklisted. The tower was eventually demolished. Much of his documentation vanished into government and corporate archives. Now look back at Giza with that story in mind. The pyramid is built over an aquifer. There is evidence of copper fittings and metal components in some of its internal structures. A conductive medium, hydrogen, humid air, inside. Insulating stone outside. Resonant cavities tuned to specific frequencies. A shape that focuses fields. Some legends and fringe accounts even talk about a golden capstone, which would have been a superb conductor at the tip. Tesla tried to build a resonant, Earth-coupled tower to draw power from the planet and send it through the atmosphere. If a much earlier civilization had stumbled on a similar principle, in stone instead of steel, it might have built something very much like the Great Pyramid. And then something happened. When you examine the upper interior of the pyramid today, you see things that should not be there if it was just a quiet tomb. In the Grand Gallery, there are scorch marks and charring on the ceiling in places, as if it were once subjected to intense heat. In the King's Chamber, the granite ceiling beams are cracked. The walls have been pushed outward by a measurable amount, as though subjected to massive internal pressure. The great step outside the chamber and some passage walls showed damage more consistent with an explosion than with slow geological settling. The interior of at least one shaft was found coated in a thick crust of salt, like something had boiled and evaporated there repeatedly. If hydrogen was being generated and compressed in those spaces, a catastrophic failure, a runaway reaction, a mistuned resonance, or a powerful external electromagnetic event, could have caused a literal internal blowout. Now line that up with what we know, or suspect, about the end of the last ice age. Around 9700 BC, there is evidence in ice cores and melt patterns of a sudden, violent climate event. Some researchers argue for massive solar storms so intense they flooded the upper atmosphere with charged particles, collapsing the magnetosphere in places and allowing incredible amounts of energy to reach the surface. The result would be gigantic electrical discharges, lightning on a scale we have never seen, and rapid heating. There are sites around the world where stones show signs of vitrification, surfaces melted into glass. There are extinction pulses for many large animals. It is not hard to imagine a scenario where a resonant stone energy device, already operating at the edge of its tolerances, gets slammed by a planetary-scale electromagnetic storm and tears itself apart from the inside. To the survivors, whatever culture operated that device would not just lose power. They would lose the very heart of their technological system. They would be thrown backward overnight. Fast forward thousands of years. Nile floods have filled low areas with silt. Sand has scoured the plateau. A new culture rises, domesticates the local ruins into its own myths, carves new faces on older statues, paints new stories on older walls. The Old Kingdom Egyptians find a gigantic, damaged, mysterious structure on a prime piece of high ground. They don't know how to turn it back on. They do know that its shape and its stones feel sacred. So they align their own theology around it. They add casing stones, causeways, smaller satellite pyramids. They write hymns about god kings and afterlives and cosmic boats. By the time anyone is writing in Greek about pyramids as tombs, the original operating manual has been lost for millennia. Is this exactly what happened? We cannot say. But we can say this: the Orthodox story, one culture, one brief window, one function, no surprises, does not match the physical evidence as well as a layered, multi-epic, multi-purpose story does. And when someone in our own time tried to revive the core idea, Earth-coupled resonance, wireless power, abundant free energy, he ran into gatekeepers of a different kind. When Tesla started scaling up his systems, he threatened business models built on coal, oil, copper, rubber, steel, and meters on every wall. Financiers who own the mines, the factories, the wires, the telegraphs, and the railroads looked at a future of cheap, wireless power and saw not human liberation, but their own obsolescence. They killed the project, buried the tower, and let the world spend the next century burning fossil fuels and fighting wars over them instead. In Egypt, academic reputations, tourist economies, and national identity are all bound up with a story that says, we already know what the pyramids are, and they are safely in the past. In that context, data that hints at unknown, older builders or unknown, functional purposes is not just a curiosity. It is a threat. If the pyramid is older, then whole chronologies have to be rewritten. If it is not just a tomb, then whole careers spent insisting it is a tomb go on the line. If there was once a high technology that worked with the earth instead of against it, and we lost it, then the comforting myth of straight-line progress breaks. We become, in that moment, not the apex of a steady climb from caves to silicon, but the latest civilization in a cycle of rise, hubris, catastrophe, amnesia, and rediscovery. That is why, I think, you see such fierce resistance. Not because the data is weak, but because the implications are terrifying. The geological scars on the Sphinx say, you are older than you think. The stellar alignments at Giza say, your clocks are set wrong. The machining marks in granite say, your ancestors knew more than you give them credit for. The muon scans and secret doors say, your greatest monuments still have not told you everything. The buried stone circles in Turkey say, complex, organized societies existed when you insist they did not. The life of Nikola Tesla says, technologies that threaten existing power structures are not just debated, they are suffocated. And the silence of the record keepers, in ancient Egypt and in our own age, says, when knowledge is dangerous to the wrong people, it has a way of disappearing. So where does that leave us? Standing in the desert, staring up at a mountain of stone that is at once impossibly old and forever new. We do not yet know exactly who first conceived the Giza master plan, or precisely how their machines worked, or why they encoded so much of their knowledge in geometry, alignments, and indestructible stone. We do not yet know whether the Great Pyramid's power plant phase was a primary purpose, a later retrofit, or one facet of a multi-layered machine that fused ritual, cosmology, and physics in ways we barely understand. But we do know this much: the story is not finished. There are still sealed doors we have not opened. There is still a colossal void we have not peered into. There are still sites we have not excavated beneath the sands, and submerged ruins on continental shelves we have barely begun to map. The danger is not that we will uncover something disturbing. The danger is that, out of fear, pride, or profit, we will choose not to look. Because the real secret of the pyramids might not just be about the past. It might be a message for the future, a reminder that civilizations which forget their true history are doomed to repeat its worst chapters. A warning that playing with immense energies without humility can literally bring the house down. And a quiet, stubborn whisper that there are ways to live on this planet, ways to generate power, tune into natural harmonies, and design for the long term, that we have not yet reclaimed. The stones are not going anywhere. The questions are not going away. What happens next depends on whether we keep treating the Great Pyramid as a closed case. Or finally admit what it really is, an open file. A live experiment. And a challenge from our forgotten ancestors, daring us to grow up enough to hear what they carved in the language of light, sound, and stone. Huizi Ali, the man, the myth, the legend. The icon aka the Dark Lord. Hashtag Revolution 2025 Hashtag Chaos Rising 2025 Hashtag South Pole Rebellion 2025 Hashtag Pyramid Power Revealed Hashtag Forgotten Masters Awaken Hashtag Sliz Legacy Lives